So we'll start the webinar. Thank you, everybody, for joining us today. My name is Joseph Salazar. I am a director at GeoScan, and this is a webinar on underground utility locating 101. So kind of the basics. Throughout the webinar, so the presentation will take about 30 minutes, and then we'll have time for questions and answers at the end. And if you have questions to ask, please type them into the Q&A chat function box that should be at the bottom of your screen on this webinar platform. And Gareth is our moderator today and helps set this up. So he will read out those questions at the end of the presentation. So we'll do the presentation first, and then we'll do the question and answers at the end. So this presentation, I used to do a lot of pre-COVID at environmental consultants or geotechnical consultants' offices, and it was designed to give a broad range base knowledge about utility locating to more sort of junior staff entering the industry to help them understand the risks and things. But now in this new world post-COVID, we have decided to turn it into a webinar today to allow people to join from any location and any company, and also myself, I guess, to provide this to people from the comfort of our office headquarters here in Burnaby. So today's presentation, Utility Locating 101, here's the agenda. I will talk briefly about GeoScan as a company. I will dive into utility locating, and I'll talk about the industry. I'll talk about registered utility locating technicians and the technologies that we deploy to locate utilities in the field and their limitations and capabilities. I'll then touch on the various reports you can expect to receive, and I'll cover at the end additional applicable services such as land surveying, concrete scanning, coring, and vapor probes. And then after that, we'll do question and answers moderated by Gareth. So again, if people have questions, please type them in to the question and answer box. Chat function on your screen there, and Gareth will read them out to me at the end, and I'll answer them to the best of my ability. No trick questions, please. Okay, let's crack on. So, introduction to GeoScan. GeoScan was formed in 2010. We have headquarters in Burnaby, British Columbia, and we now service all over BC with offices in Burnaby, Victoria, Kelowna, and Courtenay, and we're up to above 30 technicians now. Working out of we're a service-based company servicing various clients in the construction industry, damage prevention, locating utilities, and our trucks and vehicles are driving all around, servicing various clients on different jobs, whether it be for an hour or several weeks. The range is large. So here's a list of the services that we offer as a business. Utility line locating being the topic of choice today. I won't read the rest out, but full range of subsurface surveys as well as the land surveying element. And our mission statement at GeoScan is that we aim to reduce risk and add value by mapping the past, present, and future. So reducing risk and adding value is a key focus here with locating utilities. I'll talk a bit more about the risk in the next few slides. Our core values at GeoScan: excellence. We're aiming to be the best in our industry. Innovation with technologies being deployed is key. And community, we are an employee-owned business, so our employees own shares in our company, which means that they care, and we're honest. We've got to be honest with our clients. Essentially, fundamentally to our services, we survey and then provide the results of those surveys to our clients, and that allows our clients to assess risk and make decisions on their projects. So honesty is a key function of that. And our uniques, this survey was conducted to all our existing clients, and they came back with the feedback. The main ones were that we're professional, we're thorough, and our digital reports are considered the best in the business. So moving on to the main topic of today's webinar, utility locating. Let's start with the why, the problem. Why locate utilities? I just use this as like a classic example of excavation gone wrong, shall we say. So in 2007, there was a Kinder Morgan oil pipeline that was struck with by an excavator, which caused considerable harm to the environment. 70,000 litres of crude oil seeping into the Broad Inlet, and with a huge cleanup cost, not just in dollars, but in environmental damage. And, you know, not to pick on Kinder Morgan, this could have been a gas main, high voltage electrical lines, communications. It could have knocked out power and internet to an entire city block. Anything could occur when excavating or drilling, digging, breaking ground, essentially. And if we don't know what's under the ground, or if we haven't mitigated our risk and done our due diligence, then we're suddenly exposed, not just from a damage prevention, facilities damage aspect, but also from a human, you know, workers and public safety is key to protect as well. So the utility locating industry is unregulated. So anyone out there can buy some equipment, claim that they can locate utilities, and effectively offer their services to you as the client, and come to your sites, and really without any training or knowledge, there's a high chance that they're not going to do a professional or an adequate job, and therefore increase the risk of these incidents happening. So BC One Call, as most of you I'm sure might be aware of, they've got some good radio adverts out there at the moment, and they're a great service. So it's a free service. You can call BC One Call, explain your scope of work and where you're looking to do it, and they will send you all the records that they have on file for that area. Now, unfortunately, BC One Call is not mandatory. It's a membership-based association, so they're only as good as the information they have available to them. So some high-profile examples of people who aren't members would be like the City of Vancouver and Shaw Communications. And so, you know, if BC One Call doesn't have their information, they're not going to be able to distribute it. Additionally, secondly to they're only as good as the information they have, is that the records are sometimes, often, not correct. So maybe the location of the line that they're reporting on or sending information out won't be georeferenced, might not be accurate. Also, things get changed. Construction happens, modifications happen, and sometimes those records aren't kept up to date. So great service. Always use BC One Call, but also you can't you know, rely on it solely. You still need to locate utilities on site before breaking ground. I also want to raise that there's associations out there, such as the Common Ground Alliance, that's full of members and stakeholders in the industry, and they advocate for best practices, specifically when it comes to utility locating. Now, the good news, there is some professional designations out there. The Registered Utility Locating Technician designation by ASTT BC for technology professionals. So in a world where there's an unregulated industry, this allows clients to identify or see who has the sort of credentials and competence that you want working on your projects. So R.U.L.T is an accreditation that a utility locating professional can apply for. They need to have a minimum of 2 years experience utility locating, and they need to have be able to prove that they worked on and completed 20 complex projects. Complex meaning multiple utility lines, congested, using various technologies, and provide references, pass an ethics exam, and therefore get approved and receive that certification. So something to look out for to judge the competence of someone working on your projects. At GeoScan, for example, our in-house training scheme is very extensive. New technicians coming into the field have to shadow existing senior techs for a substantial amount of time, go through a full schedule of audits before they're signed off and allowed to go out to site to complete work independently. So this is key. The technologies that we're going to talk about shortly are very interpretive and require extensive knowledge and experience and skill to be operated. It is a trade. The more education and training received, the better the performance. So it's vital to recognize that, and someone who's just gone on a 2-day trading course isn't going to be at the right level to complete your projects. So I'll go into the two main technologies now, electromagnetic induction locating and ground penetrating radar. I'll just talk about EM first. So EM in basic principle works by connecting to a metallic or a conductive line using the transmitter, that box-shaped object on the right-hand side of that picture. The transmitter effectively induces a current down that line, which the receiver then picks up. The transmitter is grounded, and so the receiver effectively picks up the completed circuit. And that receiver, in the hands of a experienced and knowledgeable and skilled operator, will be able to effectively trace out where that line leads to. So it's there's several pros to EM locating. It's generally considered pretty fast and very reliable when conducting locates for metallic or conductive lines. And there's also, however, there are also limitations. Like we just said, the line itself has to be metallic or conductive. Now, that's not going to help you when there's a concrete pipe or a clay pipe in the ground or a plastic PVC pipe. However, there are ways around that. So in the top picture there, you can see there's a locator. You see the transmitter in the center of the picture. The locator there is locating some sanitary lines or storm lines, and those won't be metallic. However, we are able to, in this instance, insert what we call a duct rod down that pipe, which is essentially a metal line. So we put that rod as far down as that pipe as we can go, and then the transmitter connects to that metallic line, the rod, and they're able to trace out as far as that rod can extend down that utility. So they're able to map out the utility that way using EM. Additionally, for example, there are gas lines hooked up to residential properties that are made out of PVC plastic, but they have a tracer wire wrapped around them. So a small metallic wire wrapped around the pipe, and therefore the same process can occur where we're able to induce the current onto that line and trace out the gas pipe that way. So the limitations and capabilities, and sometimes there's ways around things. Additionally, it's worth noting that the electromagnetic field can effectively bleed onto other utilities in busy areas. So much like water, the current will like follow the path of least resistance. It'll jump to the most conductive material. So if you're locating one line and then there's another line in the same trench, you can get this bleeding that can occur, and therefore you can effectively end up tracing a line that you weren't intending to. And that again is where the skill and the experience of the operator comes in to recognize when those situations are occurring. So I'll talk about ground penetrating radar now. GPR is a geophysical technology that effectively images the subsurface a bit like an ultrasound. And much like an ultrasound, again, relies on the skill, knowledge, and experience of the technician to interpret that data. So principally, the radar works by emitting radar pulses into the ground. The antenna that you can see on the screen there is coupled with the surface, and the radar waves pass into the ground. And when there's a change of material, it causes a reflection in the data. So effectively, the radar then bounces back up to the receiver in the antenna, and then that data is displayed live on the screen that the technician's looking at. So the data in this example you can actually see is in the bottom right corner of that picture. That's what the technician's analyzing, and there's an encoder wheel attached to the antenna so that the position of any objects that are picked up using GPR can be mapped out accordingly. So there's some advantages to ground penetrating radar. It's able to locate, both plastic and metallic utilities. It's also able to identify unknown utilities. So an advantage over EM locating, where you have to physically clip on to the line to induce that current. You have to access that gas meter. You have to open up that manhole to get access to the lines leading to that manhole. Whereas with GPR, you can pick up utilities that might run directly through your site without actually coming up to the surface anywhere. So you can effectively image those utilities that otherwise you might miss or not be identified on records, for example. And there are some limitations there as well, such as it's generally slower than EM. People ask me the question all the time, how deep can GPR see? I mean, truth be told, it can see as deep as you want, because there's a range of antenna frequencies that allow the radar to travel to different depths. But the truthful answer is the deeper you're looking, the larger the object needs to be seen. And so effectively a small diameter pipe can be seen close to the surface, and larger diameter pipes can be seen much deeper. So there's a general rule of thumb, and it totally depends on the site and soil conditions, but you lose an inch in diameter for every foot you go deep. So a 4-inch diameter pipe can be seen at like 4 feet, but then it would drop out of resolution beyond that. And an 8-inch diameter pipe can be seen at 8 feet, but then again would drop out of view deeper than that. So the deeper you go in, the larger the pipe needs to be seen. And then also, because this is an antenna that's pushed along the surface, you need to be coupled with the surface for it to work, for the radar to pass through the ground. You also need a smooth, clear area. So if there's vehicles in the way, if you haven't got access to a building or something, then you're only able to scan the areas that you get access to. This is an example of different soil types and how that can affect GPR. So on the left-hand side, we're clearly able to identify a pipe there, that hyperbola, upside down U shape in the data, if you will. In the red circle there is the profile These are two profiles of the ground. So the pipes being able to be seen in sand-based soil. That's good GPR data. On the right-hand side, you've got a poor example, which is basically in like a clay-based soil, so saturated. The radar doesn't like water, so high water tables are a problem. And fortunately for us in British Columbia, this is great because generally the soils are really good, especially around the island and the lower mainland. Unfortunately, in places like Alberta, there's a lot of clay, and so GPR generally would struggle there. Okay, I'm going to move on to talk about some reports that you may expect to see from a utility locating service provider. Digital reports stating where you're working, times that the technician were there, and accompanied pictures, and then listing every utility line that was located, how it was located, using what equipment, the signal quality, and the depth that it was found at, and then any other notes that's relevant, any issues, any areas that were a problem. The more information, the better, obviously, on these reports, to again allow the client to make a judgment call on the risk. Digital sketches, these are not geo-referenced, they're there for reference only, and accompanied by a legend. Different colors represent different types of utilities. So red for electrical. These are the Common Ground Alliance. They created kind of like a standard that should be universally used. I say should, sometimes it's not. Communications in orange, gas yellow, storm sanitary in green, and blue for water, and so on. So again, spray paint marks on the ground to show where the utilities are and where they're located, and the different types, color coordinated, and then the sort of the digital photographic overlay as part of the report. So those reports come as standard, and if you're looking for something more technical and permanent, we can produce CAD, AutoCAD deliverables, and also GIS deliverables. And these are created by surveying, either using total stations or GPS, surveying the marks and then plotting them out on CAD or in GIS. And then the client receives a geo-referenced drawing, a record that's accurate and to scale of all the utilities located in an area. And we can either create the topographical drawing, like the base plan that this overlays, or we can overlay it onto an existing one. Okay, so I'll just finish up the webinar or this section of it, the presentation section of the webinar, by talking about the additional services that may be required that are applicable. Land surveying. Oh, sorry, skip forward. Land surveying. We have a land surveying division managed by a British Columbia land surveyor. So that's a BCLS. Think of them as like lawyers for the ground. Well, that's what he tells me he is anyway. And they are able to, in situations for environmental consultants, for example, where boreholes and monitoring wells are being drilled and installed, to get that elevation record, land surveying can come in use there. Also, they're able to perform legal land surveys and topographical land surveys. Something else that I've found that's relevant is concrete scanning, and especially for indoor boreholes. So you must ensure that you scan or image the concrete in a warehouse, for example, or a building before you drill through it, before you look to drill through the concrete, because they can often house electrical cables, radiant heating lines, various other objects in the concrete. So it's important to do the similar due diligence of the concrete as it is with the ground, the general subsurface for utilities. Concrete scanning is a different skill It uses principally the same technology, ground penetrating radar. However, it's a different antenna, and it requires different training from the technician standpoint. So please be aware of that. Effectively, it works by the radar passing through the concrete, and as there's a change in material from concrete to, say, steel, such as reinforcing, causes a reflection back up to the receiving antenna that displays that reflection on the screen. And so a trained technician's able to decipher between rebar, between electrical conduits, between radiant heating lines, and any other embedded object in the concrete. And again, just to show that training matters, this is a concrete scanning example of a poorly trained operator turning up to site and doing the scan on the left-hand side. And obviously, I mean, it doesn't look much. And then on the right-hand side, you get a competent and well-trained technician scanning the concrete and finding both mats of steel, the blue representing the bottom bars and the green representing the top, and then the red representing those electrical cables embedded in the concrete. And then additionally, coring of the concrete can occur afterwards. People sometimes use the drilling companies to do this. We can do it ourselves if required, completely up to the client. And then vapor probe installation. With the vapor probes, we scan the concrete first, then drill the hole and install the vapor probe. So on to more kind of sexy topics, if you will, for geophysics. Electromagnetic conductivity is a service. It's an awesome technology, and it's able to map contaminants or metallic objects. It's hypersensitive, so it does not work well in a heavily urban environment. It works better in open areas. But this example project on the right is mapping metallic waste that was buried in the ground. But there is a range of applications. Another one of note is salt contamination mapping. This was at a salt storage yard where the sump had a damage to it and caused seepage into the subsurface. So because the salt's conductive, using the EM, we were able to map out and produce this heat map, which the red indicates the most conductive areas, therefore where there was the largest salt contamination. On the left-hand side, you can see the black dashed line is where the technician made their route and collected the data on the site through the area. And then on the right, it's overlaid onto a photograph indicating the surface features and the buildings in the area. So the client was able to sort of hone in on where the contaminated areas were on this site. So just to wrap up the presentation portion of the webinar before we get to the Q&A, in summary, do your due diligence, locate utilities before you break ground, and avoid damaging property and potentially harming workers or the public. Training matters, competence matters. There's different levels out there in the industry, so a good way of indicating whether someone's a competent utility locator is if they have the R.U.L.T, R.U.L.T designation. I also want to say just this, understanding the scope of work is essential. Like I just said, concrete scanning is a different skill to utility locating, for example. So communicating all that you have to do on your project will allow the right person to turn up with the right equipment and get the job done for you efficiently and competently. And yeah, my favorite phrase, an ounce of prevention is worth a pound of cure. So thank you for that. Gareth, I'm going to hand over to you to see if there was any questions in the Q&A box for me.
Okay, thank you, Joe. We have a question from Catherine. How long does it take to get R.U.L.T accredited?
2 years. So as in, maybe the application process she's referring to. So you need 2 years worth of experience, and then you go to the ASTTBC website, and then there's like an application form. That's probably your biggest time constraint. It's just how quickly can you do it. And then once it goes through to the board of approvers, they then look at it and either approve or decline the applicant based on the criteria and everything they've done. There is also an exam in there at times. So I want to say in a few weeks, something like that. I know the board reviews these applications pretty swiftly. But again, the main chunk of time is that time for the applicant to complete the form and the exam and everything. So it just depends how much time you can dedicate to it.
Okay, great. Next question here. A few of them are coming in. What is GeoScan's current lead time to get a tech on site?
We're really busy at the moment, unfortunately. I would say 1 to 2 weeks. So as much notice in advance as possible, then we can get you booked in and the placeholder put in the schedule, and make sure we get to your site in time. I mean, even if lead time was shorter, something I would urge is, BC one call. We always place our own one calls. The client should be placing their own as well. But that information usually takes like a couple of days to come in anyway. So you should always be looking to plan these things, at least a few days in advance.
Okay, great. Next question. This one's from Nima. Why the quality of GPR is not as good in clay soil compared to sand soil?
Yeah, great question. And full disclosure, I'm not a geophysicist. I don't have a PhD in GPR, but my sort of general working knowledge and understanding is that essentially like the radar dissipates as soon as it hits the water, so you don't get any information beyond that. So saturated soils almost act as like a shield to the radar for the utilities that are buried beneath that sort of water table. Essentially, radar works it travels through different materials at different speeds. So as it's going through soil to concrete or to air, that change in speed is picked up by the data in the control unit, and that's what the technician's looking at. And unfortunately, as it hits saturated soils, that data just becomes ineligible. Sorry if that was a poor explanation, but there's some science behind that.
Okay. Next one from Brent. Are you back to snaking lines with the metal rods for EM locating? I know you stopped doing it when COVID came around.
Right. Yes. Great point. Yes, we are. Yeah, that did occur. Yeah, we're back to doing it.
Okay, and next one here is, how long does it take to scan an area, for example, a soccer field size?
Totally depends on the congestion of the area. So if we're talking like downtown, a soccer field size, days, just because of the amount of utilities that might be located in there. If you're talking rural, so like a remote area, hours. Sorry, that was a bit vague answer, but it is very site dependent and depends on the number of utilities running through the area.
Fair enough. Okay, and then the last one, unless there's a few more that come through, is can GPR be used to locate voids?
Yes, it can. Yeah, void surveys is a great one for GPR. Again, that sort of like that change in speed as the radar passes through different materials and gets reflected in the data is actually how we're able to to see voids clearly. Like as soon as it hits the air, it just, you know, dissipates, so you can pick up that data.
Okay, we'll give people a little chance. Get your last questions in. If anyone has any other queries, please type them into the Q&A box.
We're a little ahead of time as well, Gareth, which is great, obviously. But just to confirm, are you recording this presentation, Gareth?
Yes, that's correct.
Yeah. And then we'll follow up with an email with the recording for people to either send around or rewatch if they need to. After this presentation tomorrow, I believe, Gareth, is that right?
Yeah, it'll be out to every attendee tomorrow with a follow-up.
Great. And then I also just want to do a little plug for Gareth. Thank you very much for helping set all this up. And we've done previously a webinar on oil tank locating, residential oil tank locating, that was designed for realtors. And we'll look to do more of these sessions on various topics in the future. But yeah, thanks everyone for joining.
Great. I think that's